Good morning, everyone. In the last session, we discussed about what is SAGA design pattern and how to implement that SAGA design pattern by using choreography approach. So let's understand what is the development that I have done for the project. So it is working as expected. So first of all, create Maven multi-module project. Okay, we have created one Maven multi-module project. Add required dependencies. Add required dependencies in parent form. Okay, then I created one Maven multi-module project. So then I can create common bindings, create Maven module. So for this module, I have given the name as common bindings. So in that common bindings, we will create all the common classes required for our application development. Then create second Maven module, which we are calling as order service, which will take care of the order processing. Then create another Maven module, which is called payment service. So this is what we have developed. We created one Maven multi-module project. In that multi-module project, common bindings available, which will contain all the common binding classes required for our application. We have order service and we have payment service also. Order service will take care of the order processing. Payment service will take care of the payment processing. Then add the required dependencies in parent pom.xml. Add required dependencies in parent pom.xml. What are the required dependencies? Any common dependencies that are available for our application? Those are common dependencies we have added in the pom.xml. So if you see, data JPA is common for both applications. MySQL driver is common for both applications. Lombok and all the common dependencies we are adding in the parent pom. Okay. Then after it is completed, project setup. Okay. Projects setup is complete. Maven multi-module project is created. In that, parent project will be available, child project will be available. One parent project, 3 child modules I have created. One is a common bindings module, another one is order service module, third one is payment service module. And we added required dependencies in the parent pom.xml. The next one, classes development. Okay, so what are the classes that we need to create in our application? So classes development, create binding classes. The very first step, create entity classes. Now, in our project, as we have seen in the diagram, 3 tables we are using, guys. One is purchase orders table, another one is order payments table, another one is user balance table. Create entity classes. What are the entities? One is purchase order order.java, which is mapped with a database table called purchase orders table, which is mapped with a table called purchase orders table. Next one, purchase order payments.java, which is mapped with a table called purchase order payments table. Purchase orders payments table is available. And the next one, user balance.java. So which is mapped with a table called user balance table. So as we have seen in the diagram, total we are using 3 tables in order to implement this application. Purchase order table is available. To map the Java class with the table, we are creating one entity. This entity is mapped with this database table. Purchase order payments.java, it is mapped with one table. User balance.java, it is mapped with another table. So as you have seen in the diagram, purchase order table is available, order payments table is available, user balance table is available. Then after, create repositories. Create repositories for entity classes. As we are having 3 entity classes, we have created 3 repositories. Now, all the entities, 3 entities and 3 repositories I have created in the common bindings, because here order service table should talk to the database and payment service also should talk to the database. That's why as these entity classes and repository interfaces I have created inside my common bindings. Okay, common bindings development, common bindings project, right? Inside this project, I have created my entity classes and I have created my repository interfaces. Along with that, some DTOs, order request DTO, order response, okay, order status, payment status I have created. Create request under create required request and response classes. Create required request and response binding classes. Okay, so here I have created order request dto.java and order response dto.java, and I have created some enums also. One is order status enum.java and the second one is payment status enum.java. Order status enum.java and payment status enum.java, which will represent what is the status of the order and what is the status of the payment. Okay, so these are the three things that I have developed in the common bindings. Nothing else is available. So if you go to common bindings project, so in this common binding project, we have DTO, order request DTO, order response DTO, order status, payment status available. Then after entities, as we have three tables, we have three entity classes. Purchase orders table, purchase order payments table is available, and user balance entity table is also available. For these three entities, I have created three repositories: user balance repository, purchase order repository, payments repository. Once it is completed, then next part is add common bindings, add common bindings project as a dependency in order service and payment service. Order service and payment service. Why we need to add common bindings in the order service and the payment service? Why we need to add common service in the order service and payment service? Because binding classes, entity classes, repository interfaces are available in the common bindings. That's why we are adding common bindings project as a dependency in the payment service and order service. Go to order service form.xml. In the order service form.xml, if you observe, common bindings project is added as a dependency. Same thing, if you go for payment service, in the payment service form.xml also, we are having order service common bindings as a dependency. Good. So with this, our setup is done. Next one, coming to order service. So what we have done in the order service? Okay, order service project development. How we have created this order service project development. So what is the logic we need to write inside the order service project? So first one, if you observe, order service will take a request, controller will be available, then it should store the request information to the database. A service will be there talking to the repository, then it should produce the message to the Kafka topic. Okay, so order service will have Kafka producer configuration, Kafka producer config.java will be available, and Kafka consumer config is also available. Because order service will produce the message to order topic, order service will consume the message from the payment topic. So producer configuration is required and consumer configuration is also required. So if you see in the config package, consume config is available and producer configuration is also available. It is going to create a topic called orders topic. Producer configuration we are representing. Key is a string, value is a JSON. The Kafka is running on the port number 909. Coming to the consumer configuration, we are specifying that here what is the key deserializer and value deserializer. So here order service is acting as a producer and consumer. So for that we are creating producer configuration class and we are creating consumer configuration class. And the next one, we are creating one REST controller and we are creating one service. Create a REST controller and create one service. So what will be there in our REST controller? REST controller will contain the methods to receive the order request. So whenever you send the order, the request will come to this REST controller and it will go to the method. It is going to store that data into database table. Whatever the order request we are getting, we are storing that order request data into database table. We are storing the data into database table. Once the data is stored into the database table, Once we store the data into database table, then we are sending a message to the orders topic. So saying that whenever the request comes, order service will store the data into first request, first option number one flow. Whenever the request comes, it will go to order service, it will store into database table. After storing in the database table, it will produce the message to the Kafka topic. So that is the logic available. So whenever a request comes to our REST controller, what this REST controller is going to do? This REST controller will call the service method. This service method will insert the record into database table and it will publish a message to the Kafka topic. Once it publishes a message to the Kafka topic, what will happen? Payment service will consume that message and will do the payment processing and will check the balance and will send the event back to payment topic. Order service will consume the payment topic, will send the response to the user. Okay, so this is the logic in the order service. So take the order request, create the order, store the order into database, publish a message to the Kafka topic. Then here I have one method to see what all the orders available. And here I have written one method in the order service which is used to consume the message from the payment topic. So here if you see, it is listening to the payment topic, it will take the purchase order. If the payment is completed successfully, then order will be completed. If the payment is failed, order will be failed. It will update the order status in the database table. It is a listener. So these are the classes that I have. Kafka producer config, Kafka consumer config, a REST controller is available, a service is available. Inside the REST controller, there are two methods available. One is create order method is available. Another one is get orders method is available. Inside the service, what are the methods available? The method is create order and create order, save and publish message to topic. Save and publish the message to the topic. This logic is available. Inside the service, handle new order or create order. Whenever the order comes, REST controller will call our service method. Service method will call, REST controller will call the service method. Our service method will create the order, save in DB and publish message to the topic. Then one more method is available, get all orders from DB. Get all orders from DB. One method is available. And the next method, handle payments topic message. Handle payments topic message. What is the mean? Consume payments topic. Consume payments topic message. Whenever the payment topic provided a message to the payments topic, order service will consume to that message. Consume payments topic message, check payment status, check pay status, and confirm or cancel order. This is the logic. So here, order service will receive the order, it will produce the order, it will save the order in the database, and it will publish the message to orders topic. Publish message to orders topic, saying that order is created. Then there is a method to get all the orders from the database. Then there is a method consume payments topic message. Check the pay status and confirm or cancel the order. So this is the logic in the order service project development. Then coming to payment service project development. Payment service, same concept here also. Payment service project development. Kafka producer, Kafka configuration, REST controller will be available and the service will be available. REST controller is not required because we are not directly sending the request to the payment service. So inside the payment service, what are the classes we have created? So if you go to our payment service project, here in the Java folder, payment config, Kafka consumer config available, Kafka producer config is available, and payment service is available. Inside the payment service, what is the method? So the method is it is going to listen to orders topic, it will check the balance and it will send the service. Okay, handle the method here, handle order payment. So listen to orders topic, listen to orders topic. What this method will do? Handle order payment. So it is going to listening to orders topic. Listen to orders topic. Whenever the message comes, what will happen, guys? Check order amount and user balance. Okay. So if user having sufficient balance, then deduct balance, and update payment completed. Update payment completed. Then produce payment status to payment stop. This is the logic. So inside the payment service project, we will create one Kafka producer configuration. We are creating Kafka consumer configuration. Inside the service, there is a method called handle order payment method is available. So here it is going to listen to the orders topic. Whenever the order message comes to the orders topic, it will take that order. It will get that record user balance. If the balance amount is greater than purchase order, then deduct the balance and set the status as payment completed. Otherwise, set the status as payment failed. Update that in the payment table, purchase order payments table. Then produce the message to payments topic. Produce the payment status to payments topic. When the payments message produced to payments topic, in the order service will consume to that message, will check the order is payment is completed successfully or not. If the payment is completed, produce the message, update the message in the database table saying that payments completed. So this is the logic we have done. If you look at the diagram, I have given the numbering also. First, we will create the order by using Postman. It will go to order service. Order service will produce a message to orders topic. Right? So order service will save the data into database table regarding the order is created, produce the message to orders topic. Then payment service will consume the message from the orders topic, will do the payment processing. Payment processing it will done by using the balance table. Then after payment is done, it will update the payment data in the payment table. After the payment processing is completed, it will produce the message to the payment topic. So once the message produced to the payment topic, order service will consume the message from the payment topic and will confirm the order or will cancel the order. This is the logic. All of you look at the diagram. All of you look at the diagram. All of you look at the diagram. Are you guys clear with the execution flow? Good. Now, once these projects are ready, what is the setup? Kafka setup. Kafka setup. Run the Zookeeper server. The first step is run Zookeeper server. I have given the command for that. Run Kafka server. I have given command for that. Open Kafka tool. Open Kafka tool and connect to it. Okay. Then fourth one, run order service. Then run payment service. Send a request to order service. Send post request to order service and verify data. Okay. We need to run the Zookeeper server. Then we need to run the Kafka server. We need to open the Kafka tool and we need to connect to the Kafka tool. We need to run the order service. We need to run the payment service. Here, orders topic should be created automatically. Orders topic will be created automatically. Here, when you run this one, payments topic will be created. Okay, good. Now, how do we run the Zookeeper server? So we have already taken the commands for that, right? Let me open that file. SAGA pattern. One minute. Let me check the commands to start this. Hey guys, I got the Kafka nodes. So here the commands are available in order to start our Zookeeper as well as Kafka. So go to Zookeeper server. It is available in the softwares folder. Go to Kafka, bin directory, Windows directory. Open this one. I'm starting my Zookeeper first. Then start the Kafka from the same directory. Another command prompt I have taken to start the Kafka. Yes. So with this, we are able to start the Zookeeper and we are able to start the Kafka. Okay. So what next, guys? We need to open Kafka tool and we need to connect to that. As we discussed, I have downloaded Offset Explorer, which is a Kafka tool to monitor our Kafka topics and Kafka messages.
Ashok sir, how can we see our when you run it on command line, I don't see a message there. Can you show that again, please?
Which one?
The command line right here. We should see our message, right? The data.
I did not get you.
I say when we run our Kafka, right? We will see our message here, right? When it's successful.
No, it won't give any message here.
Not loading any data?
No, I will show you that. Kafka tool I am open.
Oh, okay, sir.
Okay. Go to Offset Explorer, guys. Offset Explorer is a Kafka tool which is used to monitor Kafka topics and Kafka messages. Okay. So let me connect it to this cluster. I'm connecting to the Kafka. My connection is successful. Already there are some topics created, guys. So yesterday I have tested. Yesterday we got the issue in the class, right? Later point of time I have tested and I published some messages also to the Kafka topics. Now payment processing and the messages I have seen. Okay. So these messages are created. If you see the data on the December 10th, these messages are published to the Kafka topic. Order topic is available, payment topic is available. These are already created in the Kafka server. Okay. Now, if you can see the date change, there are 4 records available starting from 0, 0, 1, 2, 3. And other topic also data. Here, data value coming in the byte array format. Change the data from byte array to string format and update. Then you can see the data in the string format. Order is created, payment status is null. Go to the payment status here also. Data coming in the byte array format, change that value to the string type and update it. Now you can see the data, payment ID will be available for that. Okay. Now, if you see in the each topic, there are 4 records already available, which are created yesterday. You can check the date difference here. 12/10, the records are created. Now, so as my Kafka server is up and running, I'm able to connect to them. Now run the order service and run the payment service. So these are the Spring Boot applications we created. We added start classes for them. Now go to order service, right click. Before that, let me connect with my database, MySQL Workbench. Which database we are connecting? I'm connecting to a database called SAGA database. In the database, the tables are available, some records available. Let me delete them. We will create a fresh database today to understand this clearly. Let me drop database SAGA. Dropping the database SAGA. Now I'm creating database SAGA. I'm using SAGA. Check the tables. Currently in the SAGA database, no tables are available. I have dropped it and I have created again. When I run my application, required tables should be created. That is the expectation, right? Now go to order service, run as boot application. I'm running my order service API. Check that console, what is happening here. Now you see the required tables are created and it connected to the Kafka. So purchase order table is created, purchase order table sequence created, purchase order payments table created, user balance payments created, and all the things are ready. Okay. Similarly, let us start my payment service also. Run as boot application. Run as boot application. I'm running my payment service project as well. When I run my payment service project, so it will insert the user balance record, some dummy records I'm inserting into the table, and it also connected to the Kafka server. Now check the tables here. Now you see the tables which are available. Purchase order payments table is available. Purchase order payments, user balance entity is available. User balance, some dummy records are inserted to see the balance is reduced or not. Purchase order table, currently no orders available. Order payments, currently no payments available. User transaction I'm not using. 3 tables only I'm using. One is a balance table, which is having some static data, which user is having how much balance. Purchase orders table, there is no order entry available. Order payments, currently there is no order payment is also available in the database. Now, I want to create one order and I want to test really they are working as expected or not. Okay, so once again, I'm showing you the Kafka topics. So if you see my Kafka topics, order topic available, payments topic available, order topic contains 4 records created yesterday, and payments topic contains 4 records created yesterday. Date you can check, date and timestamp. Okay, now let me go to the Postman and let me test this application. Let me go to the Postman and let me test this application. What is the execution flow? When I send a request to the order service, order should be created in the purchase order table. Message should be published to the orders topic. When the message published to the orders topic, payment service should consume the message from the order topic, will do the payment processing, will reduce the balance from the user table. Then it should it should update the data in the payments table. It should produce a message to the payments topic. Payments topic will consumed by order service. Order service will confirm the order or will cancel the order based on the payment status. So total there are 10 steps involved here, guys. So to understand in the better way, I have given the numbering also. Step 1, we will send a request to the order service. Step 2, it will create the order in the purchase order table. Step 3, it will produce order creation message to the orders topic. Step 4, payment service will consume the message from the order topic to do the payment processing. Payment service will do the payment processing by using user balance table. It will check amount is available or not. If amount is available, payment will be success. Otherwise, payment will be failed. How the payment happened? Is it success or failure? It will update into payments table. After updating the payment data in the payments table, it will produce the payment message to the payments topic. When the payment message came in the payments topic, that message will be consumed by the order service. Once order service consumed to that message, it is going to confirm or cancel the order based on the payment status. Then it will send final response to the client. This is the flow. So our APIs are running, our Kafka server is running, our topics are ready, everything is ready. Okay. So these orders created yesterday, December 10th, these orders created with order ID 1212. Now let me create the new order. Go to this one. So create order. Let me go and create the order. First one, get request orders. Currently, check it. Do we have any records in the database table? Currently, we don't have any purchase orders. Let us create one order. Post request, go to the body. Order ID is available here, which will be generated as a primary key value. User ID, assume that it is 101 user sending the order. Order amount is 1000. Now, you check the user balance table first. For 101 user, what is the balance? 5000 balance available for the 101 user. So when I send the order for the 101 user, 1000 rupees should be deducted from the balance. So currently his balance is 5000. If the order is a success, his balance should be updated as a 4000. Okay. So now check once again. Balance table having 101 user having 5000 balance, and purchase orders currently nothing available. Order payments currently nothing is available. Now when I send the request, all these 10 steps will be executed, guys. Okay. When I send this request, when I send the order request, all the 10 steps will be executed. When I send the request, all the 10 steps will be executed at a time. Now see this. I'm sending the post request to the order, user ID, product ID, amount, order ID. Click on send. I'm sending that request. Now you see order is created for the user with the status called order created. Now go to the database, select the balance. Earlier user having 5,000 balance, right? Now is it updated to 4,000? The user balance is deducted or not? Because order is created, payment is success. So for this, the payment is reduced from 4,000, 5,000 to 1,000. Now purchase orders table. Now you see one order is created. What it is telling? Order completed. Payment also completed. That's why order completed. Price is 1,000 rupees for the order. This product he ordered. This user ordered this product. Go to the payments table. In the payments table, you can see the for that particular order, payment also completed. This is the date when the payment is complete. As the payment is completed, that order is confirmed. As the payment is completed, order is confirmed. Now go to the Kafka, see the messages. Earlier 0 to 3 messages available for the user 1 or 2. But I have sent the order for user 1 or 2. Go to the orders topic, run this. Can you see fourth message is created for the user saying that user ID, order, what is the order he has done. One message published to the orders topic. As the message published to the orders topic, our payment service consumed that message, confirmed the payment, and produced message to payments topic. Check the payments topic, run this. Fourth record is created. Payment is completed successfully for the user ID who has given the order 1 or 2. So orders topic consume, orders topic message published, payments topic message also published. When the order is created, it is producing the message to order topic. Payment service consumed to that message, done the payment processing, produced the message to payments topic. Order service consumed payments topic and confirmed that order. So this is a distributed transaction. Now suppose let us make one more request. Now amount of the order I am giving as 7,000. User is paying the order with the 7,000. But what is the user balance in the table? What is the user balance in the table? 101 user is having only 4,000 as a balance. But order I am sending with the 7,000 balance. See the behavior of the system. Click on send. Order. I have sent it. Go to the database. User balance entity. 4,000 balance. Any deduction happened? No deduction. He is having only 4,000 balance, but he is trying to pay the 7,000. Balance not available. Go to orders table. Now, what happened for the second record, guys? First record, when he is having 5,000, 1,000 rupees order he placed. At that time, payment completed successfully, order also completed successfully. Same user making a second order with the 7,000. But what is his balance? 4,000. So what happened for the second request? Second order, payment is failed. As the payment is failed, the order also failed. Distributed transaction. Are we able to understand SAGA design pattern workflow now with a distributed transaction management? Now, same user sending one more request with the 3,000, right? Same user sending the record with the 3,000 amount. Currently, how much balance that 101 user is having? 4,000 balance is there. 3,000 rupees order is placing. He can do it because 4,000 is greater than 3,000. Make the order. Third order, same user, third order placed. Go to the balance. 1,000 rupees balance is available. 3,000 deduct. Go to orders table. Third order completed successfully because third order payment completed successfully. Order also completed successfully. Go to the payments table. Now, first time 1,000 rupees order completed. Second time 7,000 rupees order failed. Third time 3,000 rupees order completed. So the status is updating as expected. Payment completed, payment failed, payment completed. If payment completed, order will be confirmed. If payment failed, order will be cancelled. Guys, you understand? If anyone asks, what is the SAGA? You should be able to explain this diagram. You should be able to explain this diagram. Whatever the code I have done, this code I have given in the Git repository also. This code I have given in the Git repository also. Right? So yesterday, the code that we implemented with the reactive streams, the reactive streams code is giving some problems. So I have changed that code to Kafka template. So in the last session, we did not use Kafka template. We used reactive streams. With the Kafka reactive streams, we are not able to publish the message to the Kafka topic. That's why I have changed that code to the Kafka template. By using Kafka template, now we are able to implement. Yesterday code was little difficult, so that's why yesterday after our class completed, I have analyzed and I have simplified this code, guys. So initially, whatever we implemented with the Kafka streams, that was little different and difficult as well. So people are not able to understand. That's why I have reduced. I have optimized this code. This code is easy to understand. If you look at the diagram, then you can understand how the flow is executing. This is easy.
Sir, which is the main class we do exchange of message between these two entities? Which is the most important class in our coding, sir?
Sir, it's not like important class, sir. In the service class, methods are available. In the service now, if you see in the order service, there will be one method which will insert the record into table and it will produce the message to the order topic. Okay, it's not a class. It is just a method in the service which will do two things: insert the order into table, produce the message to order topic. In the payment service, there is a method. That method will consume the order topic, will do the payment processing, will update the data into database table, will produce the message topic. So here one important method, here one important method will do the complete logic execution. Okay. So that is what I have shown you, right? So when you go for order service, in the order service, order controller, when you go to order controller, create order is available. It is inserting the record into database table. It is producing the message to the top. That means step number 2, step number 3 will be taken care by this method. Create order in the order service. Insert into database table.
Sir, for the better understanding. Yes, sir.
Create order in database.
Step 3 from the diagram, that also,
Yeah.
sir.
Once the order is created in the database, then publish order creation message to Kafka top. That's it. Order is created. This method is used to get all the orders which we have in the database table. Now, what is this method? What is this method is going to do? This method is going to listen to the payments topic. Whenever the message comes to the payments topic, this method will listen to that topic. It will confirm the order or it will cancel the order, update the order status. Here, this method is producing the message to the topic. This method is listening to the message from the topic. So that means order service is acting as a producer for the order topic, acting as a consumer for the payments topic. Are you clear? Are you guys clear with my point?
Ashok, do we have any Kafka related classes or only those methods?
Kafka related classes, producer configuration and Kafka consumer configuration will be available. That means what is the key and what is the value when you are publishing a message to the topic, right? What is the key and what is the value that you are using? Key is a string, value is the object, that is JSON data. So which producer, which consumer, which topic it has to use for producing the data. Okay. Kafka producer configuration class will be available and Kafka consumer configuration class will be available. So in these two classes are same in the order service as well as in the payment service. In the payment service also we have Kafka consumer config and we have Kafka producer config. Payments topic will be used by payment service to produce the message and order service will use order topic to produce the message. Order service, producer, and will consume from the payment topic. And I can give one more arrow in the orders table. In the 10th step, actually it is confirming the order or it is cancelling the order. 10th step. Then it is sending the response at the 11th step. Because once it consumed the message from the payment topic, it will either cancel the order or it will confirm the order. That is the 11th step. 10th step is to update the order status based on the payment message. This is the diagram.
Sir, for the payment service, also mention that comment, sir. Step 4 and 5, which is doing in the code, sir.
Sure, I will update that. In the payment service, if you see order service, are you clear with the order service, right? Whenever order is created, whenever order request received, it is going to save the order into database table. Once the order is saved into the database table, so we are order request DTO is available, get order ID, order created. Then order request DTO is available. We are sending that as a purchase order. Order will be created. Then we are sending the order message to the Kafka topic. Purchase order, convert to the DTO, order request DTO. It will give order status as order created. Payment status initially will be null. Whatever the data we are coming in the binding class, we are setting the data to the entity and we are saving that entity as a message to the Kafka topic. Good. So once it is done, here we are listening to the payments topic. Listening to payments topic to confirm or cancel order. So whenever payment topic produce a message by the payment service, it will listen to that topic, will get the payment details. If the payment is a success, then order will be completed. If the payment is failed, order also will be failed. We are updating that payment status in the database table. Here, what we are doing is we are using @transactional because these two operations should happen in the single amount of time. That means if order is created in the database, message also should be published to the topic. If there is any problem in the order saving, then message should not be published to the topic. If there is a failure in the message publishing, order should not be created. I'm doing two things. One is saving the order in the database, publishing the message to the topic. Both should happen under single transaction. That's why we are using @transactional annotation. Then when we go to payment service here, go to the payment service. When we go to the payment service here, the logic in the payment service is available. What will happen in the payment service? It is listening to the order topic. Listening to orders topic. When it is listening to the orders topic, it is doing the payment transaction. So here, if the user is having the sufficient balance, then here deduct user balance and update current balance. If user balance is greater than order balance, then balance will be deducted from the user and the updated will happen in the database table. Okay. So once this user balance is deducted, then update payment status. Update payment status in DB. Then after updating the payment status in the DB, produce message to payment stop. Produce payment status message to payments, message to payment stop. That's it. Here, whenever the order is placed, it will listen to the order's topic. It will take the order data. It will check what is the balance price of the order. Does the user really having that much balance in the account? If the user is having that much balance, deduct the balance from the user and update the current balance. Then update the payment status in the database table, insert a payment record in the database table, publish a message to the payment topic. When the message published to the payments topic, what will happen? Kafka topic, it will be listened by the order service. It will check the what is payment status. Based on the payment status, it will confirm the order or it will cancel the order and will update the order status in the database table. Are you clear, guys?
Ashok, can you please explain the methods in Kafka producer config and consumer config?
We already discussed about Kafka, right? At that time, we already implemented the same classes. So what is the producer? Where is our Kafka server is available? What is the key? for the message and what is the value for the message that we are writing. So key is a string, value is the JSON data. Whatever the message I am publishing to the Kafka topic, right? The value should be available in the JSON format. So the JSON data is a payment message and order message will be available. These are the classes we are writing. These are one-time creation in the project. Configuration class for the producer, configuration class for the consumer.
Sir, where you on the Zookeeper, sir? Right now, Zookeeper is on.
Zookeeper is running on the 2181 port number, right? Manually, we are running the Zookeeper by using this command.
Okay, okay. Means what are the other services needed that currently running on, right?
Correct. Zookeeper we are running here. Kafka server we are running here. We no need to create the Kafka topics manually. Once you run the order service will create the Kafka topic, because in the Kafka producer configuration class, we have already written that logic. So create the new topic. So whenever this project is started, order topic will be created. Whenever you run the payment service, it will create the payments topic. You no need to create the topics manually. They will be created by our services itself.
In your system, where is Zookeeper running, sir? In system, show it on. In system, I'm asking.
This
Yeah.
is the command prompt. This is the Zookeeper, which will run on the 2181 port number. This is Kafka, which is running on the 9092 port number.
Okay, sir.
Good. I will push code changes. Just I added comments, nothing else, guys. I will push this status to the GitHub repository. Yesterday itself, I have given the diagram as well as the flow also and Git repository. So please go through that. You can import the code and you can try running this code in your system. So when I am creating the order, I'm sending this information for that order creation. Order ID also you don't need to send. That will be created by database. You just pass which user is placing the order, what is the product ID, and what is the amount that he is sending. So based on that, order will be created in the order table, produce a message to order topic. Payment service will consume the message from the order topic, will do the payment processing, will check the balance in the balance table. If the balance is sufficient, deduct the balance and update the payment data in the payment table, produce the message to payment topic. Order service will consume to the payments topic. Based on the payment status, it will decide whether to confirm the order or whether to cancel the order. You got my point?
Yes, sir.
Sir, order service is a business
in
service.
real life, in company project, which are based on the Kafka topic, these kind of stories or this kind of work we have to do, right, sir?
Correct, correct.
Sir, finally, we are developing here one microservices, order service, microservice.
Order service is one microservice, payment service is one microservice. Two
But
services.
how we are communicating, sir? Order service to payment service, okay, through that messaging.
There is no direct communication. That is called choreography approach, right? Order service will give the message to order topic. Once the message comes to order topic, payment service will listen. Event-based architecture, sir.
Okay.
It is event-based architecture.
Okay, yeah. That's why we are not having the controller over the rest control over the
payment service we are not calling directly. There is no rest controller, because payment service, when payment service should execute, whenever order is created, then only payment service should execute.
So now here, okay, in Eclipse, okay, you have run these two projects, right? Two servers, order service and payment service. So you will be deploying the two services, two separate individual services, right?
Correct. Correct.
And one more thing, in the transactional annotation you have given, okay, there one is a crowd database operation, other one is a message operation, right?
Correct. So both should happen in the one transaction.
If for suppose one fail, for suppose topic
rollback will happen.
Rollback will happen definitely.
Yes.
But this transaction will be for a database, right? In normal.
No, sir. Whenever the exception occurred here, the transaction will be rolled back completely. Here, if there is a problem in the message publishing to the Kafka, suppose for example, if the exception occurred here, this logic will not execute. There is no problem. Suppose if the exception occurred here, then whatever the order is already created, we should roll back the order from the database, right? Then rollback will happen. If you want, you can specify at the rate of transactional rollback on exception.class. So whenever exception occurred, it will be rolled back our database.
Okay. So here, I think we created the topic general. I think anyone can subscribe, right? Right now, we are not
Yes.
provided any restriction, maybe any
No,
security.
no, no.
For that, we can provide some security using a
Yes.
password, right?
Correct. Good guys, so please try this. Please try to implement this logic. If you get any problem, you can refer my code. My code is already stored in the GitHub repository. I have given the diagram as well. Okay.
Ashok sir, last question.
Yeah.
In your project, you were already work on many times regarding to Kafka, sir, in your project.
Yes, sir. Definitely, when you are going for microservice architecture, Kafka will be there for event-driven architecture.
In your company, I'm asking, sir. In your
Yes,
company.
we are using Kafka. I mean, almost all the services we are using Kafka.
Okay, sir.
Okay.
Hello, sir. Hello, sir.
Yeah. Hi.
Sir, in real time, payment is a third party API, no?
Yes, sir. Payment processing will done by third party. Fine, guys. Thank you. With this, I'm stopping for now. We'll meet in the tomorrow session. Okay. Thank you, guys.